So let's look at a question from Exam 1 2018 Northern Hemisphere. This was a question 4, so about middle difficulty. The diagram below shows the small circle of Earth, so latitude, with latitude 30 degrees south. You can see, okay, here's the equator, and there's that latitude of 30 degrees. Okay, 30 degrees there. The radius of this circle is labelled R. Assume the radius of the Earth is 6,400. Which one of the following calculations will give you the radius of this small circle in kilometres? Okay, so looking at this, all right, you can imagine, all right, there's another right angled triangle. There's 30 degrees, so that's 30 degrees. I'll redraw that triangle. Okay. Oops. All right. So got that R. 6,400. Okay. Yep. And we want to figure out that R. Okay, so that is adjacent over radius. Okay, over hypotenuse, sorry, to give us our radius. Now also, so that would be, what's it? Cos 30 degrees equals R on 6400. So R equals 6,400 times by cos 30 degrees. Now, if we look through here, none of those are options. Okay, because the examiners here have thought about it. Okay, and they want to make it a little bit more challenging. So if we think, we know that that angle there must be 60 degrees, so that all three will add up to 180. Now, with knowing that that one's 60 degrees, I can think, well, actually, now that is opposite that angle with the hypotenuse, so that gives us sine 60 degrees equals R over 6,400. So R equals 6,400 times by sine 60 degrees. Sorry, ran out of room there. So you can see that that matches B, doesn't it? Okay, that matches B, which is the correct answer. So there, you had to think about, the way it was presented. I'm sure that most people would have just grabbed at that because they saw the cos, but that does not match what the actual calculation should be. So you had to think about it there and think a bit, okay, I know I can figure out what that angle is. That means I can calculate that sine. Okay, so it's B. Right, from the 2017 Northern Hemisphere Exam 1, this is question 7, so this is one that is considered difficult. The latitude and longitude of two cities, A and B, are shown in the table below. We can see A has got the latitude of 50 degrees north and the longitude of 85 degrees east. B has got the latitude of 50 degrees north and the longitude of 112 degrees west. Assume the radius of the Earth is 6,400 kilometres. The shortest distance along the parallel between A and B in kilometres can be found from which one of the following calculations? Okay, so they are on that same circle of latitude. Okay, so we're thinking again of our circle of latitude, all right? Okay, so we have our equator here, and A and B are on that degree of latitude, which is at 50 degrees north. So we have to find, first off, the radius of that degree, of that line of latitude. So let's have a bit of a look. Okay, all right. Alrighty, so that means 50. So 6,400, 50 degrees. All right, now I'm looking at these answers, and they're all with that sign. So that means that they'll be using the other one there. I might actually draw this triangle a bit bigger. Okay. Alrighty. There we go. Okay, so that one there is 50 degrees, 6,400. So that means the other one here must be 40 degrees. Okay, so that already cuts out 2 options. Okay, so now we know that that distance R is equal to 6,400 times by sine 40 degrees. Okay, now for the next bit, we know this one's on longitude 85 degrees east, and this is on longitude 112 degrees west. So this one is difficult because you've got to think about the Earth. You've got to think about the planet, and think about, well, okay, the distance between them, the angle between them. We've got to go through the shorter angle. Okay, so thinking about that, that line, this circle now. If we've got our line of meridian there, so one is 85 degrees west. Okay, put that A, and the other one is 112 degrees west the other way. Okay, and that's there at B. Okay, so the angle here is 85 plus 112, so that's 197. Okay, but then the angle over here, that is 360 take 197, gives us 163 degrees. Now we're looking for the shortest distance. So here is 197 degrees between them going that way, because one is east and one is west of that prime meridian. So between them is 197 degrees. However, the other way is only 163 degrees between them. Okay, only 163 degrees between them. So that's why the shortest distance is actually A. Okay, that one. 163 degrees between them, and with that calculation. Now that is quite a challenging question, that one. Good part here is that you should have been able to at least eliminate a couple of them. And from there, maybe identify that was mathematically incorrect. So at the very least, I hope you may have been able to get to a 2 or 3 questions that you may be able to guess out of. But yes, here the answer was A.